Now this is the other problem that we have. Okay, and example number 7, page number 148. Okay, so we have a rectangle A, B, C, D, E, F, forces at A, B, C, and E. So all the inclined forces, first step would be resolve the forces. So we're going to resolve the forces at A. It's a horizontal force, so no need to resolve this. This will remain as it is. Okay, 200 Newton. This resolve the forces in this direction. So you've got 250 sine 45, 250 cos 45, and you've got this 100 Newton. This can be resolved into two forces, 250 sine 45, 250 cos 45. Okay, and I'm going to convert all the mm into meters. So the first thing that we have to understand is how to find out the resultant. Okay, we're going to find the resultant of this 4 forces, and we're also going to find out the direction. Now, how did I take 45 here? This is 45 degrees, so this will be 45. This is 45. So this is also going to be 45. Alright, so that solves the angle problem. Now, first thing is find the resultant. All of us know how to find the resultant. Okay, all of us know how to find the resultant. All the horizontal forces, 200 plus 250 cos 45, and then you have minus 250 sine, cos 250 cos 45. So this is minus 200 Newton, and all the vertical forces, 250 sine 45 plus 100 minus 250 sine 45. So this is 100 newtons. Okay, now resultant you already know, so I'm just gonna write the final answer. Direction also you know how to calculate. Substitute the values, you'll get 26.56 degrees. Now the main thing is how to find out the location. So we need to calculate the moment at point A. Okay, so we will see moment at point A, how to find out the moment point A. Now this is the moment. Let's take the first force. It is passing through A, so no need to consider that. Now the next force, it is, write the line of action. It is passing through A, so no need to consider that. This is like this, so what's the perpendicular distance here? 0.15. So it is in which direction? Anti-clockwise, so you get minus 250 sine 45 multiplied by 0.15. 250 sine 45 multiplied by 0.15. So this is the first one. So the next one is, this is over, this is also over. Let's take this 100. It will be in anti-clockwise direction, so minus 100 multiplied by, what's the full distance? 0.3. Okay, next is this one. So let's draw the perpendicular. So this is perpendicular, so this is the line of action. This will be the line of action. Okay, this is going to be the line of action. So what is the perpendicular distance from A? It is cutting here, so the perpendicular distance is 0. And it is in clockwise direction, so 250 sine 45 multiplied by 0.15. Okay, the next is this one. Let's draw the, so this is your force, just extend the line. okay, forward. So this is the perpendicular distance from A. Okay, so that is 3. So it is in which direction? In this direction, so which is clockwise direction. So positive 250 cos 45 multiplied by 0.15. Okay, so that is our value. So please calculate how much you'll get. Use your calculators, and you will get minus 3.48 Newton meter, which is anti-clockwise. Alright, so this is done. Now the next thing is, how do you find out the location? We have understood how to find out this thing. So the question says we need to find out the location and where does it intersect with the edges. Okay, so approximately draw a diagram. Okay, now how does your resultant lie? First thing, how does your resultant lie? Now your resultant is something like this. I draw the axis x and y. How will you draw your resultant? Sigma h is minus, okay, 200, and sigma v is positive 100 newtons. So your resultant will lie somewhere here, and the angle is 26.56 degrees, and this is your resultant. So now, keeping this in mind, the direction and the resultant, I'm going to draw my resultant force something like this, in this direction. Okay, and this is my A. This is A, C, D and F. I'm going to denote this as A. What is the perpendicular distance? This is your remember. What is the perpendicular distance from A? Drop a perpendicular from A to this thing. So this is, I'm going to take it as X. Alright. So I need to find out how does it intersect the lines. So I need to find out this, and I'm going to take this as P. So let's try to find out how we're going to do this. Okay. So I'm going to resolve the forces because that is easier. So summation of all the forces is equal to the moment of summation of all the moments is equal to the moment of the resultant. So I don't need X, I need A and B. So I'm going to resolve the forces of the resultant. So this is how it's going to be. This is sigma V. This is sigma H. Okay, and if I do it here, it's going to be, if this is my force, this is sigma H and this is sigma V. So let's use this and solve the problem. So moment of MA is equal to, if you consider this portion, okay, so sigma V multiplied by A, sigma H, okay, multiplied by 0. So sigma MA is already anti-clockwise, this is also anti-clockwise, so it will basically become positive. So just take the magnitude of the values. What is sigma H? Sigma H is 100, okay, minus multiplied by A, so A value is 0.035 mm or 35 mm. Okay, now consider this one. Sigma MA is equal to sigma H. So sigma H multiplied, what is the perpendicular distance? This is the perpendicular distance from sigma H, which is 0.15, and V is like this. So this will be your perpendicular distance, which is nothing but B. So, and it is minus sigma V multiplied by B. So you get 200 multiplied by 0.15 minus 100B and this is nothing but 3.48. So calculate this, you will get 0.335 mm or 335 mm is your answer. So we found out what is a resultant direction, location, which is A, B. That's it.